The Voyager mission has been exploring our solar system for decades. Now nature reveals some of its latest findings.
I personally feel like it's the greatest mission of exploration that was ever launched. It's been to so many planets, discovered so many things, and now it's still discovering things 30 years after it was launched.
Nature has just published 6 papers about the giant bubble the sun creates around itself called the heliosphere, and 5 of those papers depend on data from the Voyager 2 spacecraft. That spacecraft was launched in August of 1977 on a journey to the giant outer planets, Jupiter, Saturn, Uranus, and Neptune. Neptune, the outermost, is 30 times as far from the sun as the Earth. And today, Voyager 2 is over 80 times as far from the sun as the Earth at the very outer reaches of this giant bubble. And we are trying to reach outside of that bubble into interstellar space, and both Voyager 1 and Voyager 2 are on the journey to be the first to reach interstellar space.
Nobody has been in interstellar space, and in our lifetime there probably will not be another mission that's going to go there. So Voyager crossing to the final frontier is very exciting for scientists and probably for the public as well.
Without the sun, life would not exist. We would not be here asking the questions about it. We count on the sun for everything we are and everything we know as familiar to us here on the Earth. And it is, it's our star that's determining our environment, our existence. We're almost obliged as intellectual beings to ask the question, why is it there and how does it work?
The sun, like all stars, creates a bubble around itself, and it's that bubble that the interaction from the wind from other stars and our own sun interact. And we are now in the outer layer of that bubble where that interaction takes place. So for the first time, we're now able to observe how our star interacts with what came from other stars outside.
The solar wind is a stream of particles flowing away from the upper atmosphere of the sun. It expands to a long distance. The solar wind expands against the interstellar medium, creates a cavity that holds our solar system. This cavity is called the heliosphere.
You can make a heliosphere in your kitchen sink by just running the water into the, not right directly on the drain, but to the side of the drain. And as the water comes down, it hits the bottom of the pan and begins to rush out in all directions, pretty much equally, but not quite equally, but it rushes straight out. And it pushes back the water that's in the pan. It makes a little circle, or almost a circle. And the reason that it can't just push forever and just clean out the whole thing is because as it rushes out, it just decreases in pressure and it can't push back all that water. And so there's a finite extent to it. And that's the same thing that's happening in our heliosphere. The solar wind is rushing out, pushing back on the ions and the magnetic field of the galaxy, making a little bubble in it. And the other thing about it is the edge of the circle is very turbulent and rough.
The solar wind plasma and the interstellar plasma are coming and colliding with one another, basically. And they're producing this very complicated boundary layer of the inner heliosheath and the outer heliosheath, and the termination shock between them.
Voyager 2 has 5 key instruments on it to measure the environment in this huge bubble that's around the sun. The key measurement has to do with the wind coming from the sun. The solar atmosphere is evaporating and speeding away at 1,000,000 miles per hour, creating this giant bubble. And one of our instruments measures that wind. We measure it every day, looking for evidence that we have reached the outer edge of the supersonic solar wind. These 3 instruments measure the ions, the ionized atoms, which fill the outer part of the heliosphere. But we also measure the magnetic field, which is carried out by that ionized wind, as well as the waves in that wind called plasma waves. The instrument which measures the magnetic fields is actually on a boom which projects out this way of 13 meters, 43 feet, to get it away from the spacecraft itself, which contaminates the very weak field that we're trying to measure. And the other instrument has 2 10-meter-long antennas, one of which is here, and that measures the low-frequency waves in the wind, which tells us something important about the wind itself.
We've been studying something called the anomalous cosmic rays with our instrument.
These anomalous cosmic rays come from deep in our galaxy and have no electrical charge. Somehow, at the heliosphere's termination shock, they've been accelerated to a high energy. But Alan Cummings found surprising data from both Voyagers.
There would be more particles at low energy and fewer at high energy, and it'd be a certain way that should look. And that didn't happen, and we were really astounded. It didn't happen in Voyager 1, and so some theories were put forward. Well, maybe there was a transient from the sun just at the right time that caused those particles to kind of be disrupted in their acceleration. We didn't see them. If it had been a quiet period, we would have seen what we expected to see. So we said, okay, well, we'll have another chance with Voyager 2. So Voyager 2 went through the shock. Same thing. We didn't see what we expected to see at all. And so the origin, the source, where these particles are accelerated is a big mystery. And one of the big mysteries of the termination shock crossings.
One of the interesting surprises from the Voyager solar wind instrument was that we expected all of that energy from the million-mile-per-hour wind, when it abruptly stopped or slowed down, to heat the wind itself to 1,000,000 degrees. And what we found instead, the wind was only 100,000 degrees after it had slowed down. Most of the energy, 80% of the energy, went somewhere else.
Meanwhile, closer to the Earth, a pair of satellites called Stereo were launched to find out just how the sun's influence affects our planet.
It was not thought in any shape or form that it would make a contribution to the understanding of the boundary between the solar wind and the interstellar medium, which was so distant from Stereo's orbit. But Stereo had very capable instruments, and when you design a capable instrument, you're not quite sure exactly what you're going to get when you finally get into space. Space is full of stuff.
The Berkeley team was surprised when Stereo's STI instrument, designed to measure low-energy electrons, seemed to be receiving another kind of signal.
It was obviously detecting something else that was out in space. It could have been a spacecraft background, it could have been some detector flaw or fault. But graduate student Linghua, with a bit of sleuthing, scientific sleuthing, was able to draw out the fact that this in fact was a signal from the termination shock at great distances from the Stereo spacecraft. And we were in fact detecting some particles that were very complementary to the Voyager measurements, in the sense that they were giving information that Voyager itself could not achieve right at the site of the termination shock.
It's really quite remarkable that this spacecraft, which was launched when the space age itself was only 20 years old, has now been operating for over 30 years on its journey to interstellar space.
We're now exploring new areas that have never been explored before and will not be explored for many, many years, generations probably.
By the time the Voyagers run out of power in 2020, we should have crossed into interstellar space with at least one spacecraft, and we should be about 15 billion miles from Earth.
They'll be constantly watching what Voyager is seeing around the next bend. So, for example, when the sun becomes active again in the next solar maximum a few years from now, there'll be coronal mass ejections heading outward and colliding with the termination shock, probably causing disturbances to it, changes of shape. It's expected to be a very dynamic boundary, and so we may in fact pass in and out of it several times, even before Voyager is truly in an interstellar space that's unadulterated by anything the sun has to throw out.
Well, I think all of us feel we've been very fortunate to have been on a journey of discovery. Even if it had stopped in 1989 with Neptune, we would have had an immensely valuable mission. But for it to continue now for decades and be the first to reach interstellar space, I think it's just an incredible journey of discovery, and we're all very fortunate to have been part of it.